Picture this. Your firewall is green, your MFA passed, VPN tunnel is established, and yet your most sensitive data is being siphoned or infiltrated out, exfiltrated out of your database. There's no malware, no exploit, just valid access doing dangerous things. That's the blind spot database activity monitoring, or DAM, was built to close. Today we are breaking down how DAM actually operates, why it matters in a zero trust world, and how security teams, auditors, and DBAs, or database administrators, each see DAM differently from their areas of uh, functionalities. Let's get into it. What DAM really does at a high level. We don't want to get into technicalities. We want everyone to understand when you're coming to these security apparatus and platforms and their niche functions, where they fit in an enterprise. We want everyone from a strategic level all the way to the technical level, and even a layman to sort of have an idea. So, at its core, a DAM is not about access, it's about behavior. And that's why we are saying it is a database activity monitoring. So, that should tell you it's about behavior, it is not access. So, DAM continuously answers the following four questions: who touched the database? That is one. Then, two, from where and how? Three, what exactly did they do? And finally, the most important question is, should they have done it? So that now brings into the fray, into the picture, any impropriety that was done by a given role, by a given user, is what now you could use to enrich your logs. And we will talk about how guys in the Security Operations Center view a DAM and its functionality. But let's begin by asking ourselves how DAM sees database activities. So ADAM starts with visibility because you can't protect what you can't see. There are three main ways ADAM collects activity. And number one, the first way, is network-based monitoring. ADAM tries to evaluate. So number one, with regards to network-based monitoring, ADAM sits on a network tap or mirror port. It inspects SQL traffic going to and from the database. A powerful, agentless, but encrypted traffic can limit visibility. That is a caveat. Number two, or secondly, and we're talking about how ADAM collects activity. So at the network level, we've said if the traffic is encrypted or has no agent, then encrypted traffic can limit visibility. So that is the caveat we just spoke about. Number two, agent-based monitoring from a DAM. So this is where a lightweight agent runs on the database host. It sees everything, including encrypted and local access. And here there's more visibility because it requires deeper system access. So number three, native audit logs. So ADAM ingests logs from Oracle, SQL Server, Postgres SQL, MySQL, all these database management systems. So that it is native because all these DBMSs have their own logging engines. And secondly, from a native point of view, there's low overhead, but logs can be disabled or tampered with by an attacker. So let's look at how DAM sits in a real world deployment. A mature DAM setup combines all these three. It combines network-based monitoring, it combines agent-based monitoring, it combines that with native audit logs. So remember we said the moment you're doing network-based monitoring, this is where now a DAM will sit on a network tab or a mirror port inspecting SQL traffic going to and from the database. So this is it's powerful and it's agentless. But again, the caveat is if the traffic is encrypted, then the traffic that can limit. Then, secondly, we said the way Adam works, it could work as an agent-based monitoring, an agent-based monitor. So this is where a lightweight agent will run on the database host. It will see everything, including encrypted and local access. So this is the most visible. This is where you get the most visibility, but this requires deeper system access. That's the disadvantage. Then thirdly, we said a DAM consumes native audit logs. That is the third way that a DAM collects activity. So what does it do when it consumes native audit logs? So it ingests logs from various DBMSs that it can support. We are talking about Oracle, we are talking about SQL Server, we are talking about PostgreSQL, we are talking about MySQL. So this involves low overheads, but logs can be disabled by a shrewd attacker or a DBA who feels for efficiency they might need to turn off the logs, but this is ill-advised. You'd rather even turn those logs to another server, pipe them through another storage, and a network attached storage or something of the sort, because if you need to do a forensic investigation out of database incidents, how would you do it without the native logs? So let's look at DAM again with regards to identity and context correlation. So on step 2, we are looking at identity and context correlation. So here's where DAM separates itself from basic logging. A DAM doesn't just record a query. It could be a long query, it could be a select. It doesn't just record. So it enriches the queries with number one, a database user, an operating system user, an application name, source IP and the host, authentication method, time, location, and session context. That's how Adam answers the question, was this a human DBA or an app account behaving like a human? Remember, when we talked about privilege access, we talked about AI bots or AI agents, right? That we might need to limit their privileges. Now here, Adam will be telling you, was this a human or an app account behaving like a human, or an autonomous agent doing this? So that distinction matters a lot when you are doing post-incident reviews in the course of your security defensive work. Then number 3, the other key aspect of a DAM I want us to look at is policy and behavior analysis. Now, this is where the brain kicks in for database activity monitoring. So the DAM evaluates activity against 3 policy layers. And number 1 is the security layer. Number 2 is the compliance policies layer. And number 3 is the behavioral analytics. So let's look at this. So in a security policies point of view, what does a DAM do? So here, we are talking about access to sensitive tables, right? Privileged users' actions. We are talking about mass data reads, schema changes, suspicious query patterns. So that is the security policy. From a security policy point of view, that those are some of the issues the dam will be monitoring. Now, let us go to a compliance policies level. Here, we are talking about various standards that an organization could have probably subscribed to. Let's say, for example, PCI DSS, you're probably in the banking industry. Let's talk about HIPAA, you're probably in the health sector. We are talking about GDPR for privacy, or SOX, or ISO 27001. So here, you get time-based access rules, you get a separation of duties, and these are reports that are combined into a compliance bundle, and you can now get the picture with regards to compliance where you are. Adam provides that. Then let's look at a behavioral analysis point of view. How does Adam behave? So here you have a baseline of normal behavior that is created by Adam. First of all, it tries to learn how your database operates a normal day. And there are exceptions that may be mapped. Let's say there's a particular day that you're running your payroll, there's a particular day that you're bringing in your appraisal reports. So Adam will learn normal behavior. We will learn normal behavior and analyze any anomalies. So it will be flagging anomalies, odd hours, odd volumes, odd locations, right? So some DAM systems analyze in these are all these activities in real time. Others work post event for forensic and audit reporting. So most organizations use both. So remember, when we talk about a policy and behavior analysis, we are looking at the way a dam evaluates various activities from different perspectives. So we said there's a security policy point of view. We said there's a compliance point of view. We said there's a behavioral analytics point of view. So that essentially is how now Adam does its behavioral analysis and policy analysis. Then let's look at step 4 of how Adam operates: alerting, blocking, and response. So when a rule is violated, Adam can respond. The response might be a SOC alert in the Security Information and Events Management System, a SIEM. This could be a SOC playbook firing automatically. We have not talked about SORS, but this is stands for Security Orchestration and Automation Response. So a SOC itself is an engine of various elements, and we will speak about that. Essentially, a SOC will have threat intelligence, will have playbooks for responding to various scenarios. So a SOC is a more of a concerted effort to respond to security incidents. When an alert is fired, it's enriched, it's matched to a particular threat feed, and there's an automated way of responding to this threat. So in a nutshell, that is how a SOC works. But we're talking about a dam. So one of the responses when a dam suspects malicious activity, it could fire a SAW playbook. It could trigger that, and then there could be a ticket in, let's say, a ticketing system like ServiceNow. There could be a message to the DBA team, an email fired to the DBA team telling them, oh, at today at 3 a.m. there was this and this and this was happening. So that's how now a DBA with proper visibility will quickly tell if there was an issue or there's an issue if they're still alert, right? So some DAM systems can terminate database sessions, can drop everything. You remember we talked about snort. And we said SNOT can work as an ID, intrusion detection system, and an intrusion prevention system. And we said the distinction of the two is that an intrusion prevention system can drop traffic automatically. So that is, besides detecting, now some dumps can terminate database sessions or block queries from executing. But most organizations run DAM in detect only mode. So this is where now a DAM will essentially now fire alerts to the SIM, do a message to the DBA team, fire a ticket on the ticketing system. Let's look at why would an organization run a SIM in detect only mode. So because accidental blocking of production databases is a resume updating event. So essentially what that means is you're essentially creating an availability issue. If it was a false positive, then there could be a scenario where you are blocking mission critical to go through, right? So it is much better and much safer, even politically, to run it in detect mode instead of causing a denial of service, essentially an availability issue, in relation to the CIA triad that we are saying is it is what we are. It is like the sanctity of life when it comes to cybersecurity matters. Now, number 5 in terms of activities of a dam, it's logging and forensics. So a dam logs are designed uh, to be tamper resistant and audit ready. They capture SQL statements that ran, they capture DLL changes, they capture failed loggings, they capture privilege escalation. So these logs support number 1, incident response, number 2, insider threat investigation, number 3, regulatory audit, and number 4, legal and forensic timelines. This is where a dam quietly earns it keeps long after the incident. Again, this is where dam quietly earns it keeps long after the incident. Ponder that. So number 6, we're talking about analytics and reporting. How does a dam behave with regards to this? A dam governs teams. This is a goldmine. DAM can answer questions like who accessed customer data in the last 90 days. It can answer what did DBAs do during maintenance windows. Uh, what applications touched regulated data. And this is where now all these tools begin to converge. If you're saying that you are giving DBAs just-in-time access and your PAM already has told you the privilege, we activated these credentials and give them access for the maintenance window at this particular time frame, then you can correlate that with the operations of a dam, the reports of a dam. So that will be able to tell you, based on the activities we were monitoring, what DBAs did during a maintenance window. So you don't have to rely on the accounts of these professionals. Now, modern platform layers in um, risk scoring, user behavior analytics, one-click compliance reports. So that is what you will find in modern database activity monitoring. They will have risk scoring. Remember, we talked about vulnerabilities and how they are scored. Now here we are talking about database activity monitoring. For each activity, you're going to score how malicious, how severe, what kind of impact would this particular activity have. So that is what we are calling risk scoring for the various activities that a dam is monitoring. Then user behavior analytics, that is what you'll get in terms of reporting when you employ a dam, and one-click compliance reports. Then auditors, of course, will love this kind of a system. Security teams will rely on it, and definitely attackers will hit the level of accountability of such an organization that has this kind of tooling. Now, let's look at Adam from a security ecosystem point of view. So, as mentioned earlier, a SIEM does not live alone. So, a SIEM will integrate with various endpoint security platforms. It will integrate with SIEM for visibility. It will integrate with SOAR for response. It will integrate with identity and access management platforms and PAM for identity contexts. And it will integrate with data loss prevention platforms, DLP, for data movement correlation, which brings us to something important. As we said, a dam is quite important to various parties, and it has significance even to attackers. So, how is a dam mapped into defense in-depth layer? Remember when we talk about all these security tools, there's a layer they will fit in. How does Adam now fit in DID philosophy, so to speak? So, in a nutshell, you let me paint the picture in a brief manner. So, you will have a user, and on one end, then you'll have, besides the user, you'll have identity layer. Then after identity, you'll have network layer. Then you'll have your applications. Then you'll have your database and your data. So from that point, where do you think Adam sits? It is that point after the application. Now, so Adam lives between the database and the data layer, right? A firewall will protect the network. An identity and access management platform controls authentication and authorization, so to speak, in most areas. Then a privileged access management platform will manage privileged access. But Adam answers what happened after access was granted. So you are at that application level, you have gotten past the identity and access layer. Then what do you do next? So there's a session that is established. From there, when you give your credentials to the database, then a DAM should be able to now monitor your behaviors. A DAM should be able to know you are a normal user, you are a DBA, you are an agent that has been given credentials to access. What did you use to access this DB? So that is what we are saying. After a DAM will answer the question, what happened after you are granted access? Remember, we said number one, you look at yourself as a user. So you are a user, you are accessing a system. So you have a user, then working backwards, you logged in into these systems to gain more access. So you have the application, you have the identity, then you have the issue of the network, then you have application. Then after the application, you have now the database, then the data. So the dam will see just before you get to the data that you'll meet the dam, right? So in the last line of defense before data loss becomes data breach, that is where you find database activity monitoring solution. Let's look at a dam and how it is viewed by various roles in the database and security world. So we have the Security Operations Center, we have people in governance, risk, and compliance, and then we have now the same tool is viewed very differently, using very different lenses by all these three critical teams. Remember, there's a point we had talked about security, we had talked about policies, and we had talked about database administration. Now, From a security operations point of view, they'll be looking at the real-time alerts they're getting from the dam. They'll be looking at insider threat detection. They'll be concerned with incident response timelines, and they will also be looking at attack detection inside the perimeter. From a governance, risk, and compliance point of view, here we'll be interested in the audit trails, the compliance reporting, evidence for regulators, and risk based access reviews, right? For the database administrators, on the other hand, they'll be looking at visibility into who touched what. They'll be looking at protection against false blame. They'll be looking at safer privilege operations. They'll be looking at operational accountability. So it's a very good tool that every DBA should root for, even more than the security operation center guys, the blue teamers who are there, right? So a dam works when all these three parties trust the same data. So to conclude, firewalls stop intrusions. IAM controls access, but dams tell the truth about what actually happened inside your most critical systems, where you persist your data, your facts, your truths. In a world of stolen credentials, insider threats, and silent data abuse, database activity monitoring isn't optional, it's essential. If you enjoyed this breakdown, subscribe, share it with your security team, and stay curious, because real breaches don't always kick the door in. Sometimes they walk straight through the front door. Until next time, keep safe. Keep Gumzo Cybersecurity Podcast.